Okay, page 11 of the synchronization notes. The last section number before this was section 3 for barrier synchronization. I didn't number the SimSys RTOS 2 semaphore examples I just showed you, so they don't get a section number. So we're going to talk about some problems with synchronization. And the first problem is called priority inversion. What it is when a high priority task is blocked from running by a low priority task, but it has to be blocked indirectly, otherwise the low priority task couldn't block it. Is blocked indirectly by a low priority task. So for this to happen, it requires 3 tasks and a mutex. So most real-time OSs have a dedicated semaphore type called a mutex. They will do things like test to see if you are the owner when you try to release the mutex. So that's like an owner test on release, which RTOS2 our mutex type does as well. Anyway, we're going to look at an example of where this happened, and it was on the Mars Pathfinder mission. And so I'm going to call it the Mars Pathfinder reset problem. And there's a good description of it in the online text, section 10.5.1. And there's lots of information about this online as too. Somebody's posted a pretty nice analysis of what happened. Okay, so it used the VxWorks RTOS. So this is a product from Wind River Systems, and it's pretty common in the aerospace industry. So some students that have taken this course have worked for Wind River, others have used VxWorks. I used it back in the 90s when I was working in industry briefly. It had three tasks, and task number 1 was the bus management task. This was a high priority task. There's two parts to the mission. So there's the lander and then there's the rover, and the problem happened on the lander. So it had a couple of buses, and so the bus management task was to check one of the buses and make sure that things were moving on it and that it wasn't being blocked up. So it's high priority and it executes frequently, and it acquires the bus management mutex before checking the bus. It was a communication pipe is what it was checking, but we'll just call it the bus. Task 2 is the comm task, or the communication task. It is of medium priority, and it executes infrequently. And this is part of the reason why this problem wasn't discovered during testing back on Earth. It only came up once this thing was deployed and on the surface of Mars. It has a long execution time, which was also part of the problem, and its job was to communicate data and such with Earth. And the third task is the meteorological, or the MET data gathering task. So the metadata task, and this is low priority, and it also executes infrequently. And uses the same mutex as the bus management task. I suppose it would help to tell you what the task did too. It was gathering meteorological data, as the name indicates. So gathered such things as wind speed, temperature, barometric pressure, etc. Okay, so that's the setup, and now we're going to look at what happened.